So by combining this lightweight and also with high strength, titanium helps to reinforce airframes and also enable high performance in the jet engines. So in recent years, we also see an increasing use of carbon fiber reinforced polymer, CFRP, being used in aircraft. So due to the extremely high specific strengths, higher than most of the alloys, and there has been also a long debate whether carbon fiber will replace metals in aerospace or not. So if we put this debate aside, is there any chance that we can further improve the strength of titanium or simply reduce the density, which has an equal effect on specific strength? The answer is yes. So back in Sheffield, a new idea came up of producing this lightweight titanium fan blade inspired by alloy crystal structure. So this titanium fan blade has a porous structure made by 3D printing. So you can see here they were built in the same way with classic alloy crystal structure. Here you see a cubic, face-centered cubic, and a body-centered cubic, BCC here. So you probably have heard a lot about 3D printed alloys that Boeing, one of the largest aerospace manufacturers, has invested millions of dollars in 3D printing alloys. So, however, while we have not seen any 3D printed parts being used in aircraft yet, so one of the key challenges in 3D printed alloy parts is the fatigue life. So we can visualize a material's fatigue strength by plotting on this SN curve, which is the stress and the number of cycles. So while 3D printed parts fail much sooner than a traditional machined titanium alloys. So why does this happen? So 3D printed alloys tend to have many imperfections. Here is an example showing a fracture surface of a 3D printed parts, where you can see the origin of failure is a pore in the middle, including non-molten powders. You do not expect to see that in any part of the airplane that you're on. So a painful example is the air accident happened in 1989 in Sioux City in America, which was exactly caused by a defect in titanium jet engine fan disc, in the disc. So the origin of the fatigue crack is actually this small cavity labeled as C. So I'm sorry for the depressing photos, but I just want to show you how important fatigue is for engineering to consider as the top priority.